Welcome to the review of sequences, series, and sigma notation. This is part of Topic 1 for IB Math SL. First, let's define a sequence. A sequence is an ordered set. The set can be made up of just about anything: letters, numbers, symbols, or more. Sequences can be categorized a few different ways. One way we categorize sequences is by their length. Sequences can be finite, meaning they have a last term, or infinite, meaning they go on forever. One example of a finite sequence would be your name. It's made up of a set of letters, they have a specific order, and it ends. Infinite sequences, on the other hand, don't have an ending, and these are typically the ones that we'll study in math class. You can use the pattern to always find another term to add to the end. Another way that we categorize sequences is by their pattern type. Two types of patterns that we're going to study is called arithmetic and geometric. There are many sequences that do not fit into either of these patterns. An arithmetic sequence has a common difference, meaning that you're adding a constant from one term to the next. A geometric sequence, on the other hand, uses a common ratio. You're multiplying from one term to the next. As you can see on the screen, I have formulas for both arithmetic and geometric sequences. These formulas are provided on your Math SL formula book. That means that you do not need to memorize these. First, let's look at the first two formulas. These are called explicit formulas, or formulas to find the nth term. They help you to find any term in the sequence that you want to look for. The n represents the position of that term in the sequence, and u sub n represents the term itself. In the formula, you will need to know the first term, represented by u sub 1, the pattern, whether that's a common difference or a common ratio, and you'll need to know which term you're looking for, that's the n. Underneath that, you'll see two more formulas each. These are partial sum formulas. What they do is add together the first n terms in the sequence. So n represents how many terms you want to add, u sub 1 represents the first term, and d or r represents, again, the common difference or common ratio. The reason we have two different formulas on each side is just simply how they were simplified. If you take the u sub n formula on the arithmetic side and substitute it into that first partial sum formula, you will get the second partial sum formula. On the geometric side, if you multiply the top and bottom of the first partial sum formula by -1, you'll get the second partial sum formula. Please note that on both these formulas, r cannot equal 1, or it would make that formula undefined. Below that, on the geometric side, we have a infinite sum formula. This is when you add all the terms of an infinite sequence together. It only works for geometric and only sometimes. We do have to run a test. You must check that the magnitude of the common ratio is less than 1, and then you can use the formula. I'll have a separate video with a visual explanation for why that works in only some cases. Below that, I have what's called recursive formulas. These formulas also help you to find terms in the sequence. Their downside is that you must know the term before in order to find the next term. You can't jump ahead, but I like them because their formulas are a little bit more simple to write. You're simply stating that you take the previous term, or the one you have in front of you, and then apply the operation to that term. So for example, on the arithmetic side, it's saying take the previous term and add that common difference to get the next term. It's a little more straightforward. Below that, we have sigma notation. This is our last topic. Sigma notation is a way to do partial sums without starting at the very first term. And you can start at the first term if you make the starting point 1, but you don't have to. You have a little more flexibility. In sigma notation, there are three important parts. On the bottom, you'll see k equals a number. That k can change, but the number always tells you the first term that we want to add in the sum. There will be a number on top as well, and this will always tell you the last term that we want to add. And the sequence definition that you see in front, in this case labeled u sub k, is going to tell you the sequence that we're adding the terms from so that you can find those terms. We're going to do one example of this one together. So here I have a sigma notation. On the bottom it says k equals 2. On top it says 5. So we're going to start with term number 2 and add all the way through term number 5. You can see the sequence definition in front, k squared minus 4. Below that I have my work. So I usually suggest, at least the first few times you try this, actually writing out the terms that you want to add. Because sometimes there's a misconception that the number on top tells you how many terms you're adding, but as you can see here, if we label 2 through 5, we're actually adding 4 terms. It's also common that you would subtract the two numbers and think that we're adding 3 terms together. So I think the safest bet is just to write them all out. In this case, as I plugged in the different values of k into the sequence formula to find those terms, we got 0, 5, 12, and 21. The sigma notation means to add. So I went ahead and put pluses in there and added the numbers up and got a total of 38. That's our partial sum. This would be different if I used a partial sum formula because that one assumes you started with 1. In this case, we did not. All right, so that wraps up our review of sequences, series, and sigma. Please be on the lookout for other videos for topic 1 and let me know if you have any questions or need more details. Bye!